Hello students, myself Dr. Preety Khatri, Assistant Professor SOIT. So today we will discuss about the common bus system, where through common bus system we will discuss how the data transfer communicated between different resistors. Means the today topic is if there are various resistors, then how various types of resistors communicated through only a single common bus. So let's start the topic. So before starting, here we should know about what do you mean by a bus and the data transfer, how data transfer done between the resistors. As we have done previously in the bus system topic, what do you mean by a bus? Bus is a communication device through which different devices communicate with each other. Now here in this topic, we will discuss a diagram. In this diagram, what this structure, the basic computer has a 8 resistors, a memory unit and a control unit, right? A most efficient scheme for transferring information in a system with many resistors using a common bus. Means in the common bus structure, we are using 8 different types of resistors. We are using a memory unit and we are also using a control resistor, right? And in this, through a common bus, the information is transferred between resistors, memory and the control unit. The connection of the resistors and the memory of the basic computer to a common bus is shown in the diagram. So what are the conditions? What are these S1, S2, S0 selection lines? What are these working? So before read out or before discussing these conditions, we will move to the block diagram of common bus system. Here, this block diagram shows the common bus system, right? So this diagram completely explain about the common bus system. So before discussing what this common bus system work, how this communicate the data between various systems, first we should know about the various types of resistors and how they work. What do you mean by common bus system? Common bus system means there is a single bus. This is a common bus. As you can see, this is a common bus which is communicating like this from this. This is a 16-bit bit common bus and here. This is a common bus, right? This is a common bus. And at this common bus, there are 3 selection variables are attached that is called S1, S1, S0, S1 and S2. These are the 3 selection variables in the common bus which shows the operation how this system bus work. This is a memory unit. We will discuss it later. First, we will discuss about various types of resistors. As you can see here we are using 8 different types of resistors. The first is called AR. AR is called the address resistor. What do you mean by address resistor? Address resistor hold the address of the operand, right? It shows the address of the operand, means at which address, at which location the operand is located, and it is communicated directly through the memory or through the CPU. So address resistor, suppose there are lots of data, lots of operand are there, so it contains the address of that operand. Right? What is PC? PC is called a program counter resistor. Program counter resistor means it contains the address of next instruction. It will count the various instructions and it will locate the addresses of next instruction, right? The next is data resistor. Data resistor hold the various various operands values in the data resistor. The next is the accumulator resistor. Accumulator resistor is the most popular resistor in the resistor categories, and it is also called the processor resistor, or it is a category of general purpose resistor. Accumulator resistor basically is used, you must remember about accumulator resistor. Accumulator is used, resistor is used to store the intermediate results. Suppose if there are 2 operands or multiple operands, and if there is some calculation, right, which is done by the arithmetic logic unit, we will discuss how this is connected and what is the working of accumulator with ALU. Just here you should know about the definition of accumulator resistor. Accumulator resistor is used to store the result, to store the intermediate result as well as the final result. The next is INPR, and we will discuss that. The next is OUTR. INPR is called the input resistor. Input resistor will take the input through the keyboard, right? And the next is OUTR. OUTR is called the output resistor, which gives output to the user. The next is the IR. IR is called the instruction register, which hold the instructions. And the next is the temporary resistor. Temporary resistor hold the temporary instructions, temporary operand, temporary any type of value it is hold. So there are 8 resistors: 1, 2, 3, 4, 5, 6, 7 and 8. In this diagram, in common bus system architecture, here we use 8 various types of resistors. And what we want to show here, we want to show how these various types of resistors, these are communicated through bus. Means if suppose program counter want to send the data to the program counter want to send the data to address register, or data register want to send the data to accumulator, so these are communicated through this common bus, right? चलिए अब यहाँ पे देखिए, now let's see here, at each resistor there are 3 various types of operation like LD, INR and CLR. Similarly, in program counter, load, increment, clear, data register, accumulator, at each and every types of resistor, these types of operation are connected. What do you mean by these operations? LD means load, right? LD means load. INR means increment the value, right? And the third is CLR. CLR means clear. What do you mean by this? Any resistor has these three operations, means the resistor can enable or disable these operations. Suppose if we talk about the address resistor, when address resistor enable the load operation, means the address resistor is ready to take the input from the system bus. Clear? When the operation is loaded, when any address loaded into the address register, then the value will be incremented. And CLR, what it shows, CLR means to clear the value from the register. Clear? So we can sum up the load. LD means load, to load the value, INR means to increment the value, and CLR means to clear the value. Now here we can see there is a memory unit. Memory unit shows the size of the memory. 4096 words are there and 16 bits are there. It shows the size of the memory. We cannot use the various operations like load, increment and clear for the memory, because memory cannot do this. Memory only read the data, memory only read the data, as well as memory can only write the data. Clear? And we can see connection here. The address register is communicated with memory unit through this address line. Why it is communicated with memory address? Why? Because the address register contain the addresses, various addresses of operands. So address register can send the address to the memory unit, right? Address register can send the address to the memory unit. Clear? So memory unit is ready to read the data, or if it is on, if it on or want to take the information, then it write the data. Next, here as you can see, each and every register is taking the data. Like I am talking about like address register, it is taking the data from here and sending the data here. Like program counter is also attached with the bus, data register is also attached with the bus, instruction register is also attached with the bus, temporary register is also attached with the bus, but the accumulator is not directly attached with here. Instruction register is not, input register is not directly attached with the bus, and output register is, it's only taking the data, but output is not there. So these three registers are working differently as compared to other ones. Now we will discuss one by one. So first we will discuss how input register and output register work, how they behave differently as compared to other registers when they are connected with a common bus. Input register. What do you mean by input register? Input register is a resistor which take the input from the any input device. When it take any input from the input device, when we are giving the input from the input device through the keyboard or any other medium, then it take the input from the input bus, right? After that, the input register will send that information to the CPU for the processing. As you can see, that's why input register is not connected directly through the system bus. It is directly connected through the ALU, means it send the information to the arithmetic and logic unit, right? And after processing the information, CPU send the information to the output register. That's why here we can see the output register is connected from here but not connected from here. Why? The output register fetch the information from the arithmetic and logic unit, which is sent by the input register to the ALU from that through the accumulator with the help of accumulator, right? And from the output register, the output will be goes to the user. And in this diagram, accumulator behave differently as compared to other resistor because all other resistors are connected directly communicated. If we talk about the accumulator resistor, in the definition we have already discussed, accumulator resistor is used to store the intermediate result or to store the final result also. Now here, if we talk about the accumulator resistor take the input from the data register. Accumulator resistor take the data from data register, but the accumulator resistor, the value from the data register does not go directly to accumulator resistor. From data register, it will move to the arithmetic and logic unit. Arithmetic and logic unit will process that information, and after that it will goes to the accumulator. For example, suppose there are two operands, and if we want to do the binary addition or binary subtraction of these two operands, suppose there are two operands like 14 or 12. Suppose there are two operands. So what the computer does, first it convert them into the binary form, binary of 14 and binary of 12, right? And after converting them, it will do the addition by the arithmetic and logic unit. So binary sum done by the ALU, and after binary addition, the sum goes to the accumulator, right? If what is E? E is called here is a flip-flop which carries a single bit, right? Means E is used if after doing the operation by arithmetic and logic unit, suppose there is a binary addition done by the arithmetic and logic unit, and if carry bit is generated, if carry bit is generated by the arithmetic and logic unit, that carry bit is stored by this flip-flop. That is the working of E, right? And when the value goes to the accumulator put the value here. Also, it can use its output and send directly to ALU. Clear the functioning of how the data register, how the accumulator, these are connected through ALU. Clear? Now, okay. Now we will discuss in this. Till now, we have discussed the construction of this diagram. In this diagram, how many various types of resistors are there, how various types of operations done by the resistor, how memory is connected with the address register, and how accumulator resistor is connected with the data register through ALU. Now we will move further about the working of this operation, working of this diagram. Whole working of the system depending on the selection line, right? So we will move to the diagram of selection lines. The selection line, as you can see, address register, see here, address register connected at a location 1, program counter at 2, data 3, and so on, memory at 7, right? From 1 to 7, we have given a particular selection line values. These are the selection line values, right? So we will move to the diagram here. What this diagram says, which resistor will be selected for transferring data to the bus, means suppose when the decimal equivalent value is 1, as you can see in this diagram, the address register in the system bus connected at location 1, means at 0, 0, 1, means when the selection value of S2, S1 and S0 is 1, 1, 1, then the address register will be selected to read the input as well as to give the output. This table shows this one thing. Clear? Similarly, for all the resistors, this table shows, like for example, program counter resistor, the decimal equivalent is 2. So in binary, it is written as 0, 1, 0. What it says here, you can see program counter is located at location 2, means 0, 1, 0, means when we give at the values at selection line 0, 1, 0, then automatically through the bus the information goes here and the program counter will be ready to accept the information and give the information to the bus, right? Similarly, operation with data, accumulator, input, output, and all the which are connected through the which are connected through the system bus, right? Like at 3 location, the value will be 0, 1, 1. When the selection line will be 0, 1, 1, then data register will work. At 4 location, when the selection line S2, S1, S0 is 1, 0, 0, S2 is 1, S1 is 0, and S0 is 0, then accumulator will work. At instruction register, when the value selection line is 101, then instruction register will work, right? And temporary register, the value is selection line is 010, then temporary register will work. And here the value is 777, means S2, S1, S0 is 111, then memory unit will work. So this is the whole the organization of the system depending on this table, that is the selection line will select which register to be selected for transferring the data to the bus. Clear? So I think it's more clear from this diagram from the working. So now we will read about this. So the output of 7 or 8 resistors or memory, these are connected to a bus, and the specific output of the bus line is determined by the selection variables S2, S1 and S0. We have already discussed. And here, like for example, as we discussed, like you can take any one resistor. Like here we have discussed about the data resistor. Data resistor is connected at the location 3. Here data resistor is connected at a location 3. So what will be the selection line value? 0, 1, 1. S2 will be 0, S1 is 1 and S0 is 1. Just a minute, right? This is we will be 1, 1, 1. So then the data resistor will work, right? And what it discussed, and it also discussed about various types of operations. We can discuss about various types of resistors, at which location they are located. And here, like their memory location is at 7 locations. So S2, S0 and S0 value, when it will be 111, then memory will be active and write the operation. The right input is activated and it will be write the operation. And these are the various sizes of resistors we have already discussed when we discussed about the resistors, like data resistor, accumulator, instruction and temporary resistor. These all are of the 16-bit, and address resistor and program counter are all are of the 12 bits, right? Now come here, like for example, input and output. We have already discussed about the sizes of input and output. Input and output resistor are of the 8 bits, right? And we have discussed how input resistor giving the command, to the ALU. Through the ALU, the output goes to the output resistor, right? With the help of accumulator. Here you can see here there are 5 resistors and the 3 various types of control inputs: load, incrementer, clear. We have already discussed all these things. And the most important from this slide, the most important thing is about the flip-flop. Flip-flop E is used when the accumulator do the operation and the carry bit will go to the accumulator. And the data, how data is transferred from data register to accumulator, how the information goes from data register to accumulator. This operation shows the operation, how the values goes from the data register to input register. So I think it's almost clear from the topic about the system buses, how through not a single bus. Here I am talking about a common bus. So if in exam the question comes or a topic, what do you mean by the common bus system? Through the common bus system, how various devices, how various types of resistors communicated, then we can easily explain about this, explain with this diagram, like there are various types of resistors and how these are connected, how they are communicated, how they are shared information with various types of resistors and different through a common bus, right? So thank you all. Thank you.